Imperial Yeast is at it again with their Imperialis project, creating yet another unique proprietary strain through hybridization. In addition to its excellent attenuation and rapid reduction of diacetyl, I-10 Mangostini contributes robust ripe tropical fruit, strawberry, and lychee notes that complement modern hops. And as a Kveik hybrid, it can be fermented anywhere from 78 to 90 degrees Fahrenheit or 26 to 32 degrees Celsius without any negative issues. Head over to imperialyeast.com to learn more about I-10 Mangostini and be sure to pick some up for your next batch of fruity IPA. Welcome to the Brew Lab. While thiols and biotransformation might be the hottest topics in yeast right now, genetic engineering or genetically modified yeasts aren't far behind. If you followed the recent releases like the thiolized strains from Omega or Sourvisier from Lallemand or anything that Berkeley Yeast is up to like Tropics or diacetyl-free strains, these companies and others are doing amazing things that brewers wouldn't have imagined just 10 or 15 years ago. But what is a genetically engineered yeast? The answer is actually quite complicated. I'm your host, Cade Job, and the answer is so complicated that with me today in the lab, I've got three guests, Molly Browning and Avi Shayevitz from Lallemand and Laura Burns from Omega Yeast Labs. They recently wrote an MBAA Technical Quarterly article along with Chaz Rice from Lallemand about genetically engineered yeast, specifically the terminology, science, and regulation. Molly, Laura, and Avi all have extensive experience with yeast manufacturing, working for some of the most well-known yeast labs in the industry, and they each have some unique perspectives about this relatively new area. So we'll weave in and out between the three, but the idea is to start talking about where the industry is now on GE or GMO yeasts, like what offerings are out there, where are we going, and then sort of turn to a discussion of how we got here. What do we actually call these things? What do they do? How were they developed? Do they require any special handling? And we'll spend the last part of the show talking about how yeasts are actually developed through conventional or genetic methods and how that impacts the use of those yeasts in the brewery and what we call them. Hopefully this show gives us some cool groundwork where we can start to continue to explore GMO and GE yeasts in the future. And I hope to have each of these guests back on to go into more detail about their specific GMO offerings. But first, I wanted to say another big thank you to our patrons. None of this would be possible without you. If you're not currently a patron, I encourage you to head to patreon.com/brewlosophy and check out the monthly contribution levels. In addition to the feel-good vibes of helping to support the work we do here at Brewlosophy, you get access to a bunch of awesome rewards depending on the different pledge levels that you choose. You get access to Brewlosophy contributor recipes that we've never published, new discounts each month to YakimaValleyHops.com, and for $3, access to a monthly live Q&A session with a special guest from the brewing industry. This month's guest is Brewlosophy contributor Steve Thanos. Steve is a teacher and homebrewer with a wealth of knowledge about beer. He's so much fun to hang out with, and he can answer any questions you might have about homebrewing and conducting experiments or any of his other exploits. He'll be available in June to answer your brewing questions, so I hope you'll take advantage of this great reward by becoming a patron at patreon.com/brewlosophy. Thank you to everyone that's left a rating or review of the show. I truly appreciate hearing from you, and those ratings help other listeners like you find the show. Without those reviews, we wouldn't have the Applying the Science series with Jordan, so keep them coming, and if you haven't yet rated or reviewed the show, I'd really love for you to do so. This week's feedback is brought to you by the folks from John I. Haas, who over the last couple years have released a handful of really cool hop products like Lupamax, Incognito, and Flex, all intended to improve beer while reducing vegetal matter and thus increasing yields. Well, they're excited to announce their latest 100% hop-derived product, especially made for your patio, lawnmower, or beach beers. Kettle Ready imparts smooth, light-stable bitterness and kettle hop aroma to beer while offering microbiological protection during the brewing process. This new product is easy to use and has no special dosing requirements. Plus, due to its standardized high alpha acid concentration in a light stable molecule, it gives the light stability and bitterness characteristics desired for all traditional beers. And it plays well with other Haas products, including Tetra Hop Gold, Hexa Hop Gold, and Ready Hop, for flexibility and optionality when brewing light stable beers. Learn more about Kettle Ready at johnihaas.com. That's John, the letter I, HAAS.com. All right, listener Jeremy wrote in. He says, "Hi, Cade. So I'm making my way through the entirety of Brewlosophy and so have only just recently learned about the Brew Lab. However, I was sad to see that the first 10 episodes are not available on Spotify. Do you know why that is? Keep up the good work." Hey, Jeremy, thanks for letting us know. So we've gotten this fixed. There was just a little setting that we needed to toggle on our podcast hosting software, but it's all fixed. You should see it updated on Spotify and elsewhere. And I normally wouldn't include this kind of thing as feedback, but if you watch the recent Brewlosophy show video video on our YouTube channel, there was a reference to episode 7 as one of the most surprising things I learned on the Brew Lab. That was episode 7 where I talked to Cameron Selna about coating draft lines with hop extracts, with bitter hop extracts. And so if you were looking for episode 7 last week, you probably wouldn't have found it. So thanks, Jeremy, for letting me know. And also, if you aren't actively subscribed to the Brewlosophy Show, you are missing out. So get over to YouTube and subscribe. I'll be back in a few minutes with Molly Browning, Laura Burns, and Avi Shayevitz to talk about genetically engineered yeasts. We all know that designing recipes is really fun, and doing it well is so much easier with good software. We at Brewlosophy recently made the switch to Brewfather, and honestly, y'all, we could not be happier. Brewfather utilizes the latest technology to bring you the most robust cloud-based recipe design software that can be accessed anywhere, on your phone, tablet, desktop, and even offline. It also works seamlessly with numerous third-party devices to make it easier to monitor every step of your brew. I know change can be difficult, but trust me when I say you need to go to brewfather.app today to try it out for yourself. That's brewfather.app. Are you opening a brewery or have you already? Did you know More Beer has a pro division? MoreBeerPro.com is your brewery or brewery in planning one-stop shop for all your brewing needs. From complete brew houses and accessories to fermentation and even cooperage, they've got you covered. More Beer also has the largest selection of malt, hops, chemicals, and other brewing products of any vendor at low wholesale prices, all of which can be delivered on the same pallet, saving you and your brewery even more on shipping costs. Visit MoreBeerPro.com today to sign up for an account and talk with one of their knowledgeable brewery consultants. In my mind, there's no question that yeast plays a critical role in brewing great beer. It has an outsized contribution to beer flavor and aroma for such a tiny organism, and it's funny that for hundreds or maybe thousands of years, brewers didn't even know yeast existed. It wasn't until the 1800s that we started to understand the importance of yeast and to grow our knowledge of fermentation, but since that time, Saccharomyces cerevisiae might be the most studied microorganism on the planet, and now we're seeing the fruits of hundreds of years of research in novel genetically engineered yeasts. So with me in the lab today to talk about genetically engineered yeasts are Molly Browning and Avi Shayevitz from Lallemand and Laura Burns from Omega Yeast Lab. So welcome to the Brew Lab, y'all.
Thank you.
Thanks.
Thanks for having us.
I'm glad to have you all here. And you guys were co-authors along with Chaz Rice on a recent MBAA TQ article, which was titled Genetically Engineered Yeast, a review of terminology, science, and regulation. So that's where we came up with the impetus of the show. So I want to understand how y'all came up with the idea to write this article. So maybe let's start with Laura. How did this discussion come together?
I think it was just generally good friends in the industry kind of asking more detailed questions, trying to grasp the concepts behind the technology and what we were working on, what we were doing. And it was really just clear. Sometimes there was a lot of confusion around it. And, people would kind of be bouncing back and forth between concepts or terms. And I think, and Molly and I, we also worked together quite a bit through the Master Brewers Association. So we had a lot of conversations around this and just building a little bit more just breadth to the knowledge of the brewing industry around the topic.
Yeah, and maybe Molly, I'll talk to you next. So it sounds like you and Laura started having some conversations from that. Is that kind of where the impetus of the paper came from?
Yeah, so we serve on the Master Brewers Technical Committee, and we've organized a couple of workshops at the MBA conferences and then at the Craft Brewers conferences. And, we would always get questions that I think we thought it merited to have a broader discussion more than we could have a discussion at a conference and have a reference point, which there didn't seem to be a reference point in the brewing industry about this specific topic. That detailed terminology and just on very basic terms. And it was something that, as a non-scientist, I really wanted personally. Yeah. So I could go back and be like, oh, that's what that means. Yeah.
I totally understand that. Having a reference for this, that makes a whole lot of sense. So it sounds like, but it sounds like you and Laura had it covered. How'd you get Avi involved?
I bribed him with gummy bears.
Specifically the Haribo peach gummies. But yeah, I think part of the big thing about that is like what both Laura and Molly were saying, we got questions, or we would get questions, specific questions, and rightfully so. I think part of it really is more from an industry industry point of view, is more of transparency. Now, this isn't a sales pitch, but one of the things that we do, Sour Vizier is one of our transgenic or genetically modified yeast, which is a transgenic organism. One of the things that was specifically put on the package is bioengineered yeast. We want customers to know that what they're buying, and the information is freely available out there on the internet. You can search up the patents on the modifications that were made, the technology that was used. But I think for a lot of people, GMO is a little scary. So providing a little bit more transparency from an industrial point of view, I think, is very important for customers and for research and development scientists like myself.
Yeah, I totally agree with that, right? The transparency piece of this is so huge, because I think, for whatever reason, there are consumer perceptions about GMO and GE, and a lot of that stems from, kind of like Molly said, when people talk about these things, like, for example, a word you just used, transgenic. I don't know what that means. I assume we're going to talk about that today in today's episode. I know we are going to talk about that, so don't worry. But, we need a resource out there for people to understand what are these yeasts and what are they doing, and I mean, I think there's also opportunities for you guys have done a great job, of branding your different yeasts, like Sour Vizier. I mean, you just mentioned for Lallemand. Laura, you guys have that entire thiolized strain of yeast, which is, a fantastic, I'm going to call it family. I don't know if that's the right word. Maybe we'll get there, but a great family of yeast for improving those thiol contributions to yeast flavor. But okay, so we'll get there. So the point of this episode and the point of the article that you guys wrote was to help people understand terminology, right? Understand, what it means, how these yeasts are made, sort of peel behind the curtain and look and see what is a GMO yeast, how's it defined, what does it mean for regulatory issues, and then also what's the impact in the industry, where are these things going, what are we going to be doing with GMO yeast? So we're going to try to touch on all of those topics today, which is why I have 3 guests on this show for this episode. And of course, just a reminder of everybody who everybody is. So Avi Shayevitz has been on the podcast a couple of times, episode 15 about barrel micro and mycobiome, and episode 91 about lactic acid's impact on yeast. Avi's a brewing research and development scientist at Lallemand. We've also got Laura Burns, who's been on the show twice, Director of Research and Development at Omega Yeast Labs. And her episodes were episode 21, where we talked about STA1, those diastatic yeast strains, and then episode 44, where we talked about yeast-dependent haze. And new on the show this time is Molly Browning, Technical Support Manager and Japan Technical Sales Manager, also MBAA Second Vice President. So I wanted to ask you this question, Molly. I've asked Avi and I've asked Laura how they got into brewing and brewing science. I want to ask this question of you too. How'd you get into this?
It's better over a pint in a pub, but long story short, I was in Japan and I went up to Brian Baird and I wanted to learn about beer. I'd never homebrewed before. I knew I liked beer, but I just didn't know how it was made. Literally did not know how it was made. And I asked if he could teach me how to brew. And he needed an apprentice because it was just him. And he agreed. So that's kind of how I got started.
Wow. Yeah. And here you are now, again, technical manager and Japan technical sales manager. So awesome. Okay. So I wanted to start off then talking about sort of where we are with GMO or genetically engineered yeast, like as an industry today. And then we'll get into the terminology, methods, regulatory, and future impact. And Molly, I thought this might be a good spot for you to start. So it seems like genetic engineered yeasts have seen really tremendous growth, just even in the last few years. Can you talk about growth of GE in the industry, genetically engineered yeasts in the industry, and where we're at today?
Yeah, so this really applies to the US because that's where you're really seeing that growth. And it's a little bit of that is due to the regulatory layout and environment in the US, and how a genetically engineered yeast is defined. It also Laura can correct me on this because she's more familiar with CRISPR than I am, but the CRISPR technology that came out in the past 10 years, that really propelled a lot of work, not just within yeast, but you're looking at Impossible Foods, a lot of different products in the agricultural space. So yeast was, one of these products, and both Lallemand and Omega, we offer other yeasts that are not GMO. We offer hybrids and, conventional Saccharomyces strains as well. And there's only one other yeast company in the US that is just purely for genetically engineered yeast, and that is Berkeley. Worldwide, the regulatory landscape is a little bit different, so you don't really see these yeast elsewhere, and we can get into a little bit of why that is. But Canada is a really great example where if you have a modification that is within the same species called cisgenic, that yeast, is more likely to be able to be sold in Canada than if it was a transgenic modification, which we can get into later.
Okay, I think that'll make sense once we sort of talk about those terms. But I want to ask another question too, and I think, Laura, I'll ask you this one. Why would a yeast lab want to make GMO strains? And what's the benefit to your customers and consumers?
Well, I think, again, like Molly said, there's a kind of history to a lot of what we do. One being that yeast have been studied for decades in the molecular and genetic context. So there's so much known about the yeast themselves, like specific mutations that occur in brewing strains as they're domesticated. So we have so much information that basically allows us to be very specific and targeted to modifications that improve, flavor or quality or maybe just performance of these strains. So it's kind of like this wealth of knowledge that puts us in the position to be able to do what we do. And, with the advent or discovery of CRISPR as a gene editing tool and actually just generically the ease of genetic manipulation in yeast, this has kind of allowed us to do what we're doing today. So I think the growth and the interest in modifying yeast is really just because there's so much known about them, and we can be very specific and we can solve problems and add to, utility of these yeast and make brewers' jobs easier.
Yeah, that makes a lot of sense, right? I mean, you like you said, making brewers' jobs easier, and the technology has just blossomed. That allows this. I was going to ask this sort of question as well too, and maybe I'll toss this one over to Avi. Then there's conventional, what we will call conventional methods later on in the show, and genetically engineered methods. Are conventional strains going anywhere? I mean, you guys all are representatives of yeast companies that have both conventional and genetically engineered yeast strains. Do you see conventional strains going anywhere?
Yeah, absolutely. And they'll always play a very important role with the brewing industry at large. One of the things that I think we can kind of think about is that, at least from a brewing perspective, genetically engineered yeast is still kind of a niche product in a way. Globally speaking, though, in non-food applications, genetically modified yeast actually do, specifically genetically modified Saccharomyces cerevisiae, play a huge role in other industries like pharmacology and the pharmaceutical industry. And these have been used for literally decades. It's kind of only recently that we're now sort of moving these into a more, visible spotlight in terms of use. That being said, I don't think that conventional strains will go anywhere. Part of the technology that helped develop the capabilities to do easy and reliable genetic modifications can also be used for rapid sequencing and identification of specific markers and specific traits that you want for breeding applications as well. This will play directly into marker assisted breeding programs for producing hybridized yeast and things. So I think there will always be a role, and at least for the time being, I would say for the foreseeable future, conventional strains will probably lead the way, at least until the technology gets to a point where we can truly have personalized strains.
Right?
Made on demand to order.
On demand strains. Yeah, I mean, that's for sure, right? Brewers certainly aren't known for their rapid acceptance of change. Very, very traditional group of people, for good reason. They're making great beer. My dad used to always say, if it ain't broke, don't fix it. All right. So then I want to talk now about terminology. All right. And I think this is a good transition into that, because in the paper, you guys wrote this awesome quote, and I realized you put it in there, and I thought, oh, that makes a lot of sense. And this is what it says. It says, much of the historical conversation on GMO technology revolves around the topic of economically vital, genetically modified crop plants. So it crops and plants. And I started thinking about, I saw something in the New York Times a couple of months ago that said 90% of the corn that's consumed in the United States is GMO. And there's soy and all these other products that are basically entirely GMO in the United States. And that's kind of been the impetus for the conversation around GMO. And now, Laura mentioned that, or actually that might've been you, Avi, that mentioned that GMO yeast, as far as brewers, are still a relatively new idea, new thing that brewers are still starting to get to know. And so GMO and GE, they kind of have specific meanings in certain situations, but in other ways, it's kind of ubiquitous and people don't really know what it means. So Avi, what do GMO or GE mean? What do they stand for?
Yeah, this is precisely why we really kind of wanted to publish this article, was because there's a lot of ways of saying essentially the same thing. A rose is a rose is a rose. GMO, GE, bioengineered. When you get down to it, it comes down to, at least the definition that I prefer to use, is a modification that is done that will generally not occur in nature. So you can induce artificially specific modifications that do actually have a low chance of occurring in nature. I mean, this is how other organisms evolve. You have gene swapping all the time. This occurs at the molecular level, at the unicellular level. And I don't know, Laura, if you agree, but microorganisms are extremely promiscuous, and some are better than others at accepting DNA. But that being said, it's really all kind of the same word for one thing. Different words for the same thing. Sorry.
Yeah. Different words for the something that doesn't happen in nature. So what about that, Laura? I mean, do you see this often? This if we weren't, if it wasn't humans intervening with this, a lot of these mutations happen anyway.
It's actually, I think, again, it's always down to the context. Sometimes these words do mean different things too. Genetic modification can kind of run the gamut across really any way of an organism's DNA being modified. So it can be selective kind of domestication, just driving certain attributes of a given yeast strain. Change is an intentional change on the DNA to get the resulting aroma that you're going for, like non-phenolic. So or breeding is a modification of the DNA. The end strain is different from the parent strains. And then going as far as, modern genetic engineering, where you're using recombinant DNA techniques. So really it makes it very difficult, because a lot of it comes down to the context of how these terms are used. And when people typically say GMO, it comes back to a negative connotation for somebody a lot of the time because they think that it's potentially unsafe. They don't like how certain mega corporations have gone about their IP around their technology or their transgenic plants per se. So a lot of that historical context puts the bad connotation on the term. So then people tend to use other terms like gene editing, genetic engineering, or bioengineered because what that means to them is something different. Yeah. So these are, like Avi said, a rose is a rose is a rose in a lot of ways, but it's complicated because it does come down to context a lot of the time. And, the FDA has gone through a whole kind of reterm on what they consider, anything using recombinant DNA techniques, they consider bioengineered now. But there's a lot of subtleties within that on whether it's naturally occurring or not, and whether the product itself is containing its DNA or not. So there's still a lot of layers behind these terms, which this article is meant to address. We're trying to help to clarify if somebody has heard things where they didn't understand the context. Hopefully this provides some of that.
Yeah, providing some of the context. And that's a question that I wanted to ask you, Molly. So as the non-scientist in the group, or I assume, Molly, you're not trained technically as the scientist, right?
I mean, I have my MSc in brewing and distilling, but I'm not a microbiologist.
Well, that's all right. So you got a master's of science in brewing and distilling, but yeah, not a microbiologist. But what are you seeing from brewers in the industry, right? Whenever you're talking about GMO and GE, do you see them, just kind of going like, I don't want to understand that. It's too much time. What are you seeing from brewers whenever you talk about GMOs and GEs?
Honestly, the biggest question I get is application. It's not really a distrust of the science. It's more, how do we use these strains? And that's globally. Like, there'll be one or two people that are like, no, that's not for us. And that's fair enough, Yeah. But they're globally, I have brewers in Japan, which we cannot get these strains that actively want to use them. And we'll go through some different ways to get some. They know who they are.
That's interesting. That's kind of surprising for me. As somebody, I'm obviously not a commercial brewer either. Somebody that's training to be a brewing scientist. Not a microbiologist though, more of the chemistry side of those things. It's interesting to me to hear that, because I would have thought like a lot of reasons why people are avoiding impossible foods or GMO corn products or soy or any of that stuff, and why it's now a labeling issue in the United States is because there is sort of a distrust of the science. And that's kind of where I see is like consumer perception. But that is nice and refreshing to hear that the brewers are at least open to these, and they're more concerned just like, okay, how do I use the yeast, and not as much the science.
The ones that we get the most feedback from, yeah. I mean, there's a lot of brewers that have really good and relevant questions, and we try to address those as best we can. And we're working on different ways to do that. Like Laura and I presented, multiple times at different brewing conferences about this. But I like what she was pointing out, the point of, a lot of that bad connotation comes from, older uses of the technology where it hasn't been transparent, or there has been some backlash that really isn't relevant now. So that's, I think, I don't want to say younger generation of brewers, but I think brewers that have grown up with new forms of technology are a bit more welcoming. And if they do have questions, I mean, we don't say, hey, that's not really applicable. We try to answer them as best we can, and we try to find a solution for them. Like,
sure. Yeah, that makes sense, right? Yeah. And it's interesting too to hear that like, some younger brewers are maybe embracing this a little bit more, maybe like exposure to technology and those things. But it sounds like there's still quite a bit of brewers that are out there that are interested in using, GMO or GE yeasts. And so we talked a little bit. So again, I like Avi's definition of GMO, GE. It's like, kind of explains something that maybe wouldn't occur in nature or would be unlikely to to occur in nature. And there's a term that Avi has mentioned and Laura have mentioned, and it's this cisgenic versus transgenic. So Avi, why don't you tell us, what are we talking about there when we're talking about cisgenic or transgenic? I think you said modification. Did I hear that right?
Mm-hmm.
Okay.
Yeah, so we can think of cis versus transgenic technology, in that when you have a cisgenic organism, it'll involve maybe making multiple copies of a single gene that already exists within the genome of the organism. Whereas, so cis meaning same, right? So this is coming from within the organism.
So that would be like two yeast species, like two Saccharomyces cerevisiae, mating and then having an offspring, and that offspring would be a cisgenic organism.
You could think of it like that, yeah. Typically, in a cisgenic organism, when it's specifically engineered, you are doing what we call self-cloning. So you're either multiplying, or you're creating multiple copies of a gene of interest to increase rates of expression, or you're doing some kind of modification that somehow alters some sort of metabolic process within the gene, but it's all occurring within the same organism for the most part. Whereas transgenic is, you are taking a gene from a taxonomically separate organism and inserting it into another organism that would not necessarily be sexually compatible. So it could be something like, say, you have a human insulin is a really good example. The way that the pharmaceutical industry produces human insulin is they use transgenic E. coli to produce insulin in vats. Prior to that technology, we used porcine insulin to treat diabetes. The side effect of that is, over time, people will develop severe allergies to it, and you had to find another source of insulin. So now, using this technology, where you're using a transgenic organism to mass produce an otherwise unavailable life-saving molecule, that's a game changer right there. So, kind of like in the industry here, at least I can talk about a little bit, say, like proof of concept organisms, where we can take a single gene from a taxonomically separate yeast, so say something from like Hensenia spora, and insert that into a Saccharomyces genome. That would be a pretty common example of transgenic.
I see. So maybe like tying this back to like a yeast example might be something like let's say, for example, like yeast, you want to improve its alcohol tolerance or something like that. So yeast already, uses sterols and lipids to augment its cell wall to help its tolerance in high ethanol environments. So you might take a gene and like upregulate that expression so that yeast survives better in alcohol. And that would be like a cisgenic modification. Good example or no?
We could certainly try and see what happens.
Okay. Yeah.
But I mean, that's part of the iterative process.
Yeah. Laura.
Sorry, Laura.
Yeah, I would say also with cisgenic, the idea behind cisgenic is you're not taking any foreign DNA. It's all within the yeast cell that it would naturally have access through mating, actually. You can activate a gene. You can change a gene based on what exists in the natural gene pool. You can turn the gene off. Those are all examples of cisgenic approaches. And actually, if you think about all of the traits we have in brewing strains, like maltose utilization, flocculation, phenolic character, ester quality, all of those are different, like between strains. But you could essentially take, like what one of the examples that Omega's done, just one single base pair mutation in the ferulic acid decarboxylase gene that naturally is occurring in the gene pool, and put that into an organism that is POF positive yeast and make it POF minus. And that's cisgenic because it's a change that already exists in that gene pool.
Yeah.
So that's, I guess, like turn it on, turn it off, alter it based on its variability just found in nature. That's cisgenic. So working within the organism's gene pool. So like if I wanted blue eyes or brown eyes, I could do that and it'd be a cisgenic change in a human.
Yeah, because it's already something that's in humans. I mean, it's already a trait that's in that's in yeast, for example, or humans. Yeah.
Exactly. Yeah.
All right, that makes sense. And so, and both of these are, I mean, whether it's cisgenic or transgenic, what we're talking about here is a kind of like the type of genetic manipulation, the genetic engineering that you're doing, right?
Yeah.
Yeah. Okay. Well, awesome. And so I think this kind of provides us a natural segue because I want to dig into some of these methods, right? I want to talk about, okay, how do we affect these changes? And then I want to compare them also to what we would call, quote, conventional methods. So let's do that right after this break. One of the biggest improvements to my brewing practices was the upgrade to stainless steel, and Delta Brewing Systems offers some of the lowest prices on high-quality stainless gear, like the Firm Tank, which holds 8 gallons or 30 liters of wort, comes with a domed lid to reduce the chances of a messy blow-off, and it can hold up to 4 psi of pressure. Delta Brewing Systems also has their own line of brew kettles, as well as one of the lowest-priced all-in-one electric brew systems out there, and their prices are remarkably affordable. If you're in the market for legit stainless gear that won't break the bank, you've got to check out deltabrewingsystems.com. Regardless of where you land on how to define genetically modified organisms, if you live in the US, odds are you regularly consume GMOs, and if you're like me, you probably don't even know it. Over 90% of the corn grown in the US is GMO, and it was bred to improve disease and pest resistance, to reduce the use of herbicides and pesticides, and also to improve yield, helping farmers earn a living. And similar research is going on with barley, and brewers' yeasts are now being evolved, not just for improved foods and beverages, but also to better understand fundamental biology. And during the break, we were having this really interesting discussion. I wish we had got it recorded, but we're going to try to recreate it now. And it was this talk, Laura had brought up an important distinction, right? We've said several times, genetic engineer with an ending that's different. Yeah. So like, talk to me about that, Laura, exactly what you were talking about there, like with genetically engineered versus genetic engineering and the important distinction there.
Yeah, I think that the overall, just to think about it as like two distinct kind of sets of terminology. One is referring to the method, how an organism was modified. And then 2, you're referring to the actual change or the organism. So like if you're saying genetic engineering, that is a method. You've used that to change the DNA of an organism. If you call an organism genetically engineered, now you're talking about the change that occurred in that organism. So so like with cisgenic, for example, you can talk about a cisgenic modification and a cisgenic organism, and they're subtly different. One's talking about the method or the change of the DNA, and the other is talking about the resulting organism. And I think that's just important because that comes into a lot of regulatory terminology when, like, certain, especially in the global context, certain governments are more concerned with regulating the technology and the methodology than they are the resulting organism. So an example of this would be if you use gene editing or genetic engineering to make a cisgenic change, the resulting organism didn't introduce any foreign DNA. So now a government may say we're less interested in regulating that change or that methodology because what the result was isn't kind of normally what you'd find in the organism's genome or gene pool. So that's similar to like the Canadian regulatory framework. Novelty determination is the starting point, and when you discuss the change, then the change is kind of the decision maker. So is the change cisgenic? Would it be naturally occurring? Can kind of happen on its own. And that's the starting point in Canada. And in the US, it's really just, did you use genetic engineering? Have you changed with this methodology? Did you use CRISPR? And that's the starting point. So you have to then go through all of the regulatory process, regardless of the resulting organism. It's just more focused on how you did it. So that's how it's so like kind of confusing, again, why we did provide you with this kind of terminology review, and also just a lot to navigate.
Yeah.
You know,
yeah, gosh.
As somebody doing this, it's definitely something that you have to get into the nitty-gritty of all of the ways these terms are used.
Yeah, gosh. I mean, I start to think about like it's a totally different kind of like frame of reference, right? And in Canada, you're kind of looking at the end product and then assessing, you know, the organism itself that's produced. But in the U.S., it sounds like you said that you're you know, way more focused on what method was used or how, you know, the process that resulted in the organism, which is fascinating, and it's fascinating to think about that. But I guess it makes a lot of sense as you start to like think about, well, what's more important to you? You know, in terms of the way that you want to regulate this or the way that you want to approach, you know, making sure that these organisms are safe or whatever for consumers, right? Like, where do you want to look? And there's a bunch of different ways to do that. So we need to spend a little bit of time talking about methods then, because I think that'll help us understand the regulatory landscape whenever we get there. And so we kind of talk about conventional method, in the paper, you guys talk about conventional methods and genetic engineering. And I want to start with genetic engineering because I feel like this is where, you know, we've spent a lot of time discussing the terminology, and we might have to introduce a couple of new terms at this section. But let's talk about genetic engineering and what you guys mean by that. So Laura, why don't you take us away from there, or starting there?
Yeah, sure. So genetic engineering is really just another term, recombinant DNA technology. It's when you're using specific methods to introduce DNA, and it's not through a conventional method, like breeding. So you can do this by just bombarding the cell with DNA, which is the early transgenic crops. So you just used what they call a gene gun, shoot a bunch of DNA in, and wherever it sticks, it sticks. Wow. And that's an untargeted method of genetic engineering. And what has become much more easily is a targeted method. And those are because we have a lot more tools at hand, these site-specific nucleases that allow us to cut DNA at specific sites, and then we can target the DNA to anywhere in the region or in the genome instead of it just going in randomly. So, so untargeted insertions was old technology. More modern breeding technology involves gene editing tools or those site-specific nucleases that let you target it to a specific location. So we're much more purposeful in what we do, and we can also do a lot more. Actually, like you can go in and do that one single base pair change in the genome instead of just rely on inserting a new gene and hoping it sticks somewhere.
That's like what you talked about with the POF, the ferulic acid decarboxylase, I guess was it? It was just that one base pair. You changed that one, and now you've converted a POF positive yeast into POF negative.
Yeah, and without CRISPR, that is nearly impossible. I mean, we did it through domestication, which is also super fascinating. Like, you know, decades and centuries of brewing with these, we evolved these traits through domestication. But now we can do that in literally like 2 weeks because we know a lot more. We have a lot of information at hand, and we can do those specific changes.
Well, and that's right. You talked about like we know so much about yeast's DNA, right? We know so much about the genome. It's been, I think it was it the first organism that was mapped? That was in your paper, right?
Sequenced, yeah.
It was the first, right? Yeah.
Yes.
The genome.
Eukaryote, anyway. I think bacteria was done before that. But
there we go. The first eukaryote that was mapped, but that was still relatively recently. I think 1996, if I remember correct. I apologize if I got that term wrong, but I think that's right. And so that's really interesting. We know a lot about the DNA, and so it's cool to think that you can use technology to change just a single base pair, or you can make a lot bigger changes, right? Like you can change bigger swaths of the DNA, or do something different. And you talked about kind of two major methods of gene editing in the paper, and that was transient and stable DNA transformations. Tell us about those.
Yeah, so to do these methods of CRISPR recombination, you need kind of a transient expression, which means that it's only in there when you're using selection, which is like usually an antibiotic resistance marker. So you put the DNA in and it's on the same DNA strand as the antibiotic resistance gene, and use antibiotics to select for that DNA. And then that carries that DNA until you remove the selection, and then the cells just get rid of it. And so that's all just not in the organism's DNA. It's DNA that just stays with the organism under selection. And then a stable modification or transformation, it means that it's now in the organism's DNA and it no longer needs selection. And it's going to be there forever and ever until we domesticate it out. I don't know. It's not something that we will lose.
Mm-hmm. Yeah, it's becomes part of the DNA. It's part of the genome at that point going forward for that organism.
Yeah. So the method of modifying an organism involves transient DNA expression to allow those nucleases like CRISPR and the guide RNAs to be expressed. And once that editing occurs, that's a stable transformation of the DNA, and then the transient DNA is lost.
I see.
So it's all part of the method of changing and engineering that DNA.
I see. Yeah, it's not like you're unrolling out a DNA strand and you've got it on your tabletop and you go like chop like something and then put something in, right? This is an organism that's alive, and so to do that you've got to use that transient DNA. That's where the CRISPR gets expressed, and then that DNA gets inserted into the genome as part of an organic process. It's not like an actual human that's inserting the DNA. It's through this process.
Right. CRISPR's the machinery. And it is. It's like the DNA surgeon. And then when it's all done, that surgeon's gone and the DNA is fixed or changed, or so it's very. My friend actually refers to it as kind of like a surgery. The surgeon doesn't leave in the tools when after they're done doing the surgery. Everything's gone.
Yeah, right. Everything's gone. Yeah, hopefully. Yeah, exactly. Hopefully that doesn't get added in there. That's really interesting. To think about. So one of the questions I wanted to ask was, and we know like all of this is, we know that this is all happening, right? All of the steps that are required. It's just like a medical procedure, like the surgeon. You know exactly what tools you need to put them in to do exactly what genetic change that you want to occur. There's nothing like random. It's basically exactly like a surgeon going in and fixing or cutting something out, or making a change in an organ in a human. And so I want to compare this a little bit with what we would consider like a conventional method. So Avi, why don't you take us through a couple of conventional methods? I mean, I know you were involved in the making of Novologger, which is a hybrid, I understand.
Yes. So actually, the brunt of the labor for the actual physical construction of these hybrid yeasts were done by my excellent colleagues at Renaissance Biosciences, whom we work very closely with. So I cannot take credit for the construction of Novologger, but I did did a lot of work on the project itself. So this is a 100% lab created Saccharomyces pastorianus. It has all the hallmarks of a naturally occurring Saccharomyces pastorianus, the lager yeast. It checks all the boxes that we classically define a lager yeast as. And would I consider this a genetically modified organism? Yes.
Oh, okay.
But,
yeah.
and again,
Technically.
Technically, yes. If like based off of the previous descriptions that we have given, regulatory wise, no, it does not. It is not a bioengineered product. It does not fall into the category of a bioengineered yeast, but it is a hybrid. This is a man-made or a laboratory-made hybrid that was directed using entirely conventional techniques. So this was bred using competent breeding yeast. And I keep forgetting, like this, there's a lot of dense nomenclature here. So when I say competent breeding, it means that these are yeast are able to produce spores that can then be used to breed the way that these specific fungi breed. And don't even get me started on fungus breeding. Like they're almost alien in that respect. It's bizarre.
I do want to do an episode on fungus breeding, just to have as the title of the episode. No, but I think I understand what you're saying, right? I mean, it's just they're capable of breeding together, right? They're capable of producing offspring.
Yeah. So we kind of refer to those as competent breeders. So the way that these were constructed, and there's an excellent paper that I can send you a link to if you want to include it with the description, that kind of lays out the technology used for breeding these Novolagers specifically, and similar hybrids. I mean, it's becoming more and more mainstream just because of the technological advances that we have in sequencing and high throughput sequencing and screening technologies. But yeah, like for all intents and purposes, this is an entirely, we basically sped up the process of what took hundreds, if not thousands of years of random interactions to produce modern industrial strains of Saccharomyces pastorianus, and kind of shorten that down into a few short years to produce what we can ostensibly call group 3 hybrids. If your listeners are familiar, we have the Saaz and the Froberg groups of lager yeast that we kind of refer to as group 1 and group 2. And so this is kind of like group 3. It's genetically distinct. It has different ratios of Saccharomyces eubayanus to Saccharomyces cerevisiae subgenomes, and which makes it genetically distinct from the Saaz and the Froberg, but still functions exactly like you would expect a lager yeast to behave. The difference being is that this was specifically hybridized and bred to incorporate a specific mutation that significantly reduces the production of hydrogen sulfide during fermentation. So this is part of the MET10 signaling pathway. So hydrogen sulfides is actually an important signaling molecule for yeast. But this is why you don't want to completely eliminate it, but we can significantly reduce it. And as a sulfur compound, humans are extremely sensitive to that. So one of the cool side effects was that now you have a lager fermentation that produces no detectable, or at least, sensorily detectable sulfur aroma, which is really cool. But it's cryotolerant. It ferments mellobiose. It's got a semi-domesticated Saccharomyces eubayanus subgenome.
Yeah, and it's interesting. What you said is you sped up, hundreds or thousands of years of what would have been natural processes like domestication. Like, for example, that's how, almost all brewers' yeast are domesticated yeast, right? They're so this is a process that's taken place over the entire time that humans have been brewing. These yeasts have become domesticated, and there are things like random mutagenesis, which is a word that I also learned from your paper, and we don't have to go into that, but I can sort of guess that's like, random mutations that happen, I guess that's kind of like that Jeff Goldblum quote from Jurassic Park, right? Life finds a way. There's that piece of it. But so it's really interesting though to hear. So like Nova Lager is not considered a GMO yeast, at least in the United States. And this is kind of back to anywhere, right? Yeah. And this is kind of back to what Laura was talking about. Like if you look at the end product here, you could theoretically have done the same thing using CRISPR or Cas9, right? You just used a different process to get to this point. Is that right? Or fair? I mean, that we may not know exactly how to do it. I'm just saying like it could be like theoretical, right?
I was just going to say too, is like hybridization versus genetic engineering and random mutagenesis. They all have different applications. It's not like if I was to make a hybrid of two different yeast species, the CRISPR would be like way over cumbersome than just using mating techniques. And, random mutagenesis and hybrids or breeding result in a lot of like interesting things that you might not expect. CRISPR, you kind of have to know what you're going for. You don't get new. It's really, I'm now making this combination and changing the organism very purposely. I think that maybe the sense of discovery is more in the random mutagenesis and breeding, but it also takes a lot more work to screen through that and to know what the result, was and that you wanted.
Yeah, I think that's exactly where Avi was going, right? He was about to say like, no, I don't think you could make the same yeast using CRISPR, right? The CRISPR is a targeted approach, and this has got a whole bunch of, this a whole genome that looks entirely different. I mean, you change way more than just one base pair.
Exactly. Right. I would say, just kind of reiterate what Laura had been saying previously. It's very precise. This is precision, kind of like you use CRISPR-like technology for very precision applications, whereas something like this, where you actually need to incorporate whole subgenomes of an entirely different organism, but still, within the same taxonomical clade, hybridization is the way to go, much more efficient. And then you can kind of just start breeding out from there because, Nova Lager went through many iterations before we got the final product. And it's, like Laura said, is that kind of like method of discovery is really cool too, because you can end up with some really neat combinations that you might not expect. I mean, you're dealing with a living organism that's constantly repairing and fixing its own DNA and multiplying. But actually, I think that this might also be a good time to kind of introduce about or maybe bring up the topic of CRISPR. A lot of people keep hearing CRISPR in the news. I think it is important for viewers or for listeners to know that CRISPR-Cas9 technology is actually patented IP. This is something that we don't necessarily make use of specifically, but there are very closely related, very similar technologies that are kind of offshoots of that we can make use of. I think that from a clarity point of view, you could probably do a whole podcast on CRISPR tech itself as well. But
maybe. Yeah, and the use of CRISPR, you're able to do it. You just have to license through the owners of those patents, which is not very straightforward because it's still kind of a interference and understanding exactly how that's going to lay out. But I think the bigger thing is there are other methods that aren't CRISPR that work very similarly. They don't all work the same, but there's a lot of things that can be done using all of those methods. Yeah.
So what I'm hearing is like targeted precision, right? CRISPR and these sort of gene editing are sort of like with precision. You're targeting some areas and then making changes to do something. Maybe, for example, like the thiolized strains that you guys have. As my understanding is those are gene edited, right? Those aren't like hybrids, right, Laura?
Yeah, that's right. And Sauerwitzia is also gene edited. You have the ability to make use of yeast homologous recombination, get to specific sites of the genome using what has been accessible for more than a decade or two, and then CRISPR just gives the kind of opens it up a little bit more to be targeted to different regions of the genome and making cisgenic changes.
Mm-hmm. Yeah. And Molly, of course, thinking about you as the technical sales lead of Japan, right? You mentioned earlier, you're not allowed to sell these GMO yeasts in Japan, right?
Correct. Yep.
Yeah. So like the regulatory, they've decided that I guess for whatever, well, maybe I'll ask you, like, why not? Have they said why?
So, yeah, they have really strict regulations. I believe that cisgenic is allowed, but under certain exceptions. I'm not entirely clear what those are. But, for example, like sake yeast were one of the earlier modifications. And it was just, I think the modification there was just removal of a trait. But overall, like, it isn't really... something you see over there. It isn't really accepted widely. But I mean, part of this research for this article was understanding people's perceptions. And like Laura and I separately, we did straw polls last year about just overall consumer acceptance within the brewing community. And the results we got back were pretty overwhelmingly like positive. And yes, we want to learn more about this. So yeah, I mean, I do think the interest is out there, and you do see attitudes changing, particularly in areas of the EU and the UK, for example. So
yeah, and we were talking about, and also during the break, that in the United States, that to get a yeast approved, it still has to be GRAS, right?
Yep.
And remind me what GRAS stands for and what that process looks like.
I'm going to turn it over to Laura because she's actually done more GRAS applications than I have.
Yeah, Laura, take it away.
So it's generally recognized as safe, which can be the historic use, right? So things that have been fermenting beer for years and years and years. So lactobacillus, Saccharomyces cerevisiae, Saccharomyces what am I blanking? Lager strains. They are all historic and don't need regulatory like write-ups on their safety. But anything that's under development, and I think it was 1986 that it was when the regulatory framework was established. Those are now all through kind of the GRAS program for its food additives primarily, which is what yeast fall under. There's other regulatory like pipelines for agricultural products, but for yeast, the regulatory pipeline that we go through is GRAS, and that's through the FDA. So for GRAS evaluation, you're just establishing safety. You're making sure that the donor organism, or wherever you're getting the DNA from, is safe. The DNA is safe that you've taken from that organism. The host organism, the one that you're going to be expressing it in, is safe. So it's just, basic establishment of safety for toxicity, allergenicity, any sort of like potential hazard to a human that would be consuming that.
Yeah, and of course, GRAS is generally recognized as safe, right? I mean,
that's right. Yeah, generally recognized. Yeah,
you're making the yeast product generally, giving it that label that it's generally recognized as safe, and thus can be used as a food additive. And so, right. But I think you also mentioned earlier this concept of bioengineered, right? And that's also a definition that comes into play.
Yeah, and so that's more under food labeling by the FDA. So when genetically engineered corn or genetically engineered microbes are used in a food, then those would fall under the National Food Disclosure, what is it called?
You guys had this in the paper, the National Bioengineered Food Disclosure Standard. There we go.
Right. Yeah. Which actually is for food, and because the labeling of beer is regulated through the TTB, there's actually a difference there. But as a yeast supplier, because it's a food additive, we fall under a category which we are required to label as a bioengineered. So the language, though, again, is just GRAS is a regulatory framework to establish safety. Bioengineered is the labeling requirements that if an organism is genetically engineered, or plant or food is genetically engineered, then it requires that label.
I see. And you mentioned earlier that it doesn't matter what process you use. If it's genetically engineered, it's going to have to go through grass, right? It doesn't matter the perspective of whether you're just looking at the final organism or the method. In the U.S., it's all method dependent.
Yeah, and that applies to enzymes or any sort of like if you're extracting one recently that was up that I saw was miracle fruit or miracle berry. There's a lot of, things that people don't really understand or it's not a historic example of safe food to consume. That goes through the same regulatory framework as our engineered yeast.
Yeah, I see. And so, okay, Molly, so then back to you. So we've got all of these really amazing new tools, right? Like gene editing and CRISPR, and, we can do targeted, genome manipulations. We can do hybridizations like like Novologger. Where are GMO and GE yeasts going? Where's the industry going?
I mean, yeah, I think we're still going to explore new avenues, at least in the yeast sense. It's in the wider brewing community, people are exploring the use of genetic engineering for crop resistance, disease resistance. It's a little bit more complicated, as Laura and Avi touched on, that genomic structure, including with hops as well. Still, it's really complicated. But, there is that idea of these type of techniques would be really helpful for to help with like climate change, with disease, with drought, any kind of heat resistance, just to give, farmers and brewers a sense of consistency in their raw materials coming forward. And I mean, that's something that these yeasts do provide consistency, that you know what you're getting. And they also provide, in addition to the flavor benefits, also consistency and some cost saving practices in terms of production. So either with the thiolized yeast or with sour BCA. One note, I want to go back to like the whole GMO bioengineered topic. It's still, the reason we wrote this, of course, was because it's still very confusing, and we talked about all the layers and everything. And you can even see that on the packet of sour BCA. Like, we have bioengineered, but our owner, Jean, we're a family-owned company, he was very insistent that we put GMO on there. So we were absolutely clear, even though technically you could argue that it's not the most accurate statement to put on sour BCA. Yeah. So it can get confusing.
Yeah, so there's like interesting nuances and layers even in labeling, and as Laura mentioned, if it goes into a beer, there's no longer a labeling requirement in the United States. It's just right. The yeast itself that has to be labeled.
If the beer goes overseas, though, then yes, you would have to be aware of that importing country's requirements.
Yeah.
So.
Yeah. That makes sense. And so are you getting requests from brewers? Like, are brewers coming to you saying like, hey, it would be awesome if you could make a yeast that does this?
Sometimes,
yeah.
Sometimes we just have we have very active imaginations. So, yeah, I mean, there's certain things we can do, and there's certain things that are more difficult to do, like Avi was saying. So it's just kind of like, what's the best use of our time and resources?
Yeah. Oh, and that actually reminded me too. I remembered whenever you were talking about like the labeling, right? In the United States, it doesn't have to be there, but if you ship it overseas, it does have to, it has to, you may be subject to some of those regulations. And you mentioned Jan wanting to specifically include GMO on the package. That was one of my questions that I was going to ask you guys. So like myself, I wouldn't necessarily know if I'm consuming a GMO product unless it was labeled on the package. And are there ethical questions involved with labeling this? Do you think there need to be labeling restrictions and then things?
This is something we've had a chat with the Brewers Association about. We have been trying to have conversations at CBC about this. Some are more well attended than others, I would say. So it's from from our yeast provider standpoint, we are transparent to the brewers that buy, and we will say absolutely to consumers that they ask. But it's more like educating the brewers on what this is, and for them to feel comfortable to talk to their customers, and say, yes, this is, no, this isn't, for us to give them a toolbox. And we're still working on that ourselves because of the questions that we get from brewers. And for example, like we're going to start, we're working on a website on our new website page that's coming to explain more fully what, genetic engineering and what we've done and what Sour VCA is, just to explain more about that. So yeah, I mean, we are involved like pretty heavily, I would say. Like Laura and I and Avi are pretty heavily involved in these conversations at a higher level with these industries, within the higher brewing industries, like the MBA, ASBC, and the BA. So, yeah, we're continuing to have the conversations.
Yeah. All right. Well, and then Laura, I want to sort of transition over to you, and then Avi, I'll ask you sort of this a similar question. Do you have any fun, genetically engineered strains that you want that you think brewers might enjoy?
I mean, I think there's definitely the thiolized yeast, which you mentioned. There's both cisgenic, transgenic versions of those using yeast enzymes or using bacterial enzymes. So go down to the terminology. And I think those have been really cool because it's really just a interesting new flavor that we can get out of the barley malt, primarily providing more tropical kind of wine-like character. So that's been very cool. And again, some of the cool things that these yeasts are bringing to us in the U.S. market and for brewers is just education, understanding of like the potential of yeast and what's really cool, that what we didn't know about the process or the yeast metabolic activity that can be used and be very cool.
Yeah. Avi, how about you?
Yeah, part of what I get to do is I get to mess around with a lot of proof of concept products, probably stuff that'll never make it to the market, just because one, there's really no market for it, and two, sometimes some of these modifications can be pretty complex, and then scaling that up to production can be a little bit difficult. But that being said, like the stuff that I get to play with, is pretty cool. I honestly wish I can go more into it, but don't worry, there'll be some cool stuff.
I know. I always have to ask and just hope that somebody might spill some beans on the show or something like that at some point, but that's okay. All right, rapid fire. So I asked this question of all my guests at the end of the show, and I'll start with Laura and Avi since they've had a chance to prepare this, Molly, and then I'll come to you. So I'll start with Laura first, and it's this: if you want brewers to take away one thing from today's episode, what would it be?
I think it's just that we're here to help explain. And that's the purpose of writing the article. We're trying to be as transparent as possible behind all of the aspects of, the technology, the resulting change, all of it. And I think it's really important to do that because that's how we gain trust with customers, and we wouldn't want it any other way. We really do want to be transparent and give you guys all of the information you need to make a decision on whether or not to use this, and whether or not you think it's safe or not. So it's just open book. We want you to understand it and be transparent as possible.
All right, awesome. Avi, what's the one thing you want brewers to take away?
Yeah, don't be afraid to ask questions. Anything that concerns you, or like, I know we threw a lot of big words, like stuff that typically is, you kind of have to have a background in the biology or in bioengineering to kind of fully appreciate it. But if anything is confusing, I can absolutely reach out. I believe you include my contact, like my work email, and
I've never included it on the show notes, but I will. If anybody wants to reach out to me, I'd be happy to put you in touch with Avi.
Perfect. Yeah, because this is a pretty big topic. It's dense, and I don't think that we can really fully get into the the real juicy bits we can in the time that we have. But absolutely, I highly encourage you to do some research, find some interesting papers, or reach out to industry experts.
All right, and Molly, one takeaway from today's episode.
I think everybody said everything, but yeah, we're here for education, and we're here, to answer any of your questions. So, please ask. And also, I guess a little plug for like the MBA and ASBC, like they're really great resources to reach out if you have more information. So yeah, they're good places to start your search.
Yeah. And of course, there will be a link to the article in the show notes of this episode to that MBAA TQ article. Again, I guess I'll go ahead and plug it now. It's a Genetically Engineered Yeast, a review of terminology, science, and regulation, published in the MBAA TQ volume 59, number 3 in quarter 3 of 2022. So if you've got an MBAA membership, go ahead and take a look at that. And Molly, Laura, and Avi, hey, this was fun. Thank you so much for joining me in the Brew Lab.
Thank you.
Yeah. Thanks for having us.
Thanks for having us. I thought it was a lot of fun too.
Yeah, I mean, that's great. And I love that you guys are such a wealth of information. It's always been a pleasure to talk with you. So, all right, well, thank you for listening. Next week, Jordan and I will be back applying the science to what we learned today about genetically engineered yeast. The Brew Lab is a production of Brewlosophy, where they who drink beer think beer. Don't forget to visit brewlosophy.com to read about our weekly experiments and other brewing adventures, and listen to us talk about it on our other show, the Brewlosophy Podcast. Thanks to all of our sponsors and patrons that help make this show possible. If you'd like to receive a reward for helping us do what we do, visit patreon.com/brewlosophy to see how you can do just that. Thanks so much for listening. We'll be back in the Brew Lab with another guest next week. Until then, think beer.